Alright, today we'll be looking at lenses. Okay, this is the part whereby we have actually an object, a glass lens, okay, and we shine a light ray through that particular lenses, and we see how light ray actually behaves after passing through the lenses. Okay, now before we look at the details, let us understand what do we mean by lenses. Okay, lenses in a nutshell is actually a piece of glass or plastic with curved surfaces. Okay, there are two types of lenses that we are looking at. This is what we mean by the converging, okay, whereby you have this design, okay, and the other one we have is a diverging lens, okay, whereby the lens is actually bent in this way. Okay, this is what we mean by diverging lenses. These are the two lenses that we have in the syllabus, and in the primary lens that we are interested in is converging lens. We will look at details at what are type of images formed when we use converging lens when the object are at different locations. Okay, now the lenses, the characteristic of lenses, okay, this is what we have. Okay, before we look at how image is produced, we need to understand different parts of the lenses. Okay, now for lenses, what we have what we known as the principal axis, or what I usually call the normal or the baseline, the horizontal line. Okay, it passes through the optical center. Optical center here is referred to the center of the lens, okay, which is denoted by the symbol C. Okay, this is what we call the optical center. Okay, and principal axis is the horizontal line that runs straight through the optical center. Okay, that's usually what we always call the baseline, where it's like our reference point, our ground level. Okay, this is optical center, as I mentioned. Okay, and one characteristic about optical center is this. Okay, when you have ray passes through optical center, one of the characteristics of ray passing through optical center, this point C, is that it will actually not be refracted. It will actually go straight through. Okay, if I shine the light at different part of the lens, you will find that the lens converging ray, the lens will actually behave differently. It will actually converge, or what we call focus the lenses, and the ray will actually bend at different angles. But if I pass the light ray through the optical center, okay, this particular point, you'll find the light ray will just go straight through without any bending, and that's what we mean by optical center. Okay, now other than that, we have the other characteristic of lens, which is your focal point. Focal point is what we call the point whereby light ray actually focus at. Okay, and the ray that is focused at is always the parallel ray. Okay, if I shine through the parallel ray, okay, which is parallel to what? Parallel to the principal axis, you'll find that all the light ray will actually converge to a certain point. Okay, and that point is on the principal axis, and it is what we call the focal point. Okay, and focal point, there's actually two of them. Okay, the front and the back. So which means that if I shine the light ray from left to right, my focal point will be here. If I shine on the other way, right to left, my focal point will be on the other side of the lens. Both focal point is a mirror image of each other. They will be at the same distance. Okay, focal point of a lens is a characteristic of the lens. It tells us how what is the focal point of the lens, and what is the strength, or what's the strength of the lens that we are talking about. Okay, then we have this thing called focal plane. Focal plane, loosely defined, is actually what we call the plane whereby the focal point is actually parallel to the principal axis. Okay, now if you look at the characteristic of the lens, you'll find that the common thing that we look at is actually what we call the focal point, okay, and the optical center, and the last one we look at is actually the focal length. Okay, focal length is actually the distance of the focal point to the optical center of the lens. Okay, this will actually tell us the type of lens we are holding, what's the focusing power of the lens itself. Okay, usually there's a standard fixed symbol that we use. For example, focal length, okay, I'll use denote by a small letter F. If it's focal point, I'll denote it with a capital F. Okay, these are the standard symbol that we use in lens. Optical center, I will denote it with a capital C. Okay, now once we understand the basic layout of the lens, now let us look at how light ray actually behave, okay, after passing through the lenses, or Okay, now when light ray passes through the lenses, one thing we know about converging ray is that it will actually converge. It means all the ray, when it shines through the lenses, all the light ray will actually be shrink or will actually be focused at a single point. So which means all the light ray will actually be bent at different angles. Okay, but they will be focusing on a certain point. So how do we locate the actual ray directions? Okay, we have standard rays. We have 3 standard rays that we look at. Okay, because all the light ray, remember, all the light ray, they bend at different angles. Okay, but surprisingly, there are actually 3 particular light rays that will always bend at a fixed angle, a fixed location. Okay, for example, let's trace back the step first. For example, we have a light ray, parallel light rays. You find that these angles are actually bent at different angles. Okay, and if you look at rays, they are not just these 5 rays, there are multiple rays that's in between. Okay, it just depends on how finely we divide them. There are multiple rays, and as a result, when they enter and exit the lenses, there will be multiple light rays focusing at a certain point. Okay, they will be bent at a certain angles, they will bend at different angles to be exact. But one good thing about all this is that there are actually 3 rays that will have standard or fixed movement. Okay, and the first ray that we're looking out for, the first ray, they have a fixed movement. The first ray is whereby the ray actually pass through the optical center. Like I mentioned before, if any ray that pass through optical center, it will always go straight through. So the first ray that has a fixed appearance, that have a fixed destinations, is ray number 1 that passes through optical center. It will go straight through. Okay, so this is what we mean by without bending. Okay, this has a fixed, this ray that passes through this location, optical center, always has the same outcome. Now, then we have ray number 2. Ray number 2 is slightly different, okay, in the sense that the ray actually travels parallel to the lens principal axis first. Okay, this is the ray that we are talking about is actually traveling parallel to the principal axis, and upon entering the lenses, okay, it will bend at a certain angle. Okay, so when it exits from the lens, it will be focused, it will bend. So where would the light ray cross? Okay, parallel ray, when it exits the lens, you will find that it will always pass through the focal point of the lens. Okay, this is what we mean by a fixed outcome. You'll find that if the light ray is parallel, okay, to the principal axis, you will find that the outcome is standard, is fixed. Okay, it will always pass through the focal point of the lens. Okay, the third ray that we are looking out for with a fixed outcome is the reverse of a ray number 2. Okay, but I call this ray number 3. So now what we have is, I will have the light ray passes through the focal point first. It will pass through the focal point. After that, you hit the lens. So after it hit the lens, what happens is it will actually emerge from the lens, exit from the lens, parallel to the principal axis, just like the reverse case of ray number 2. Okay, so now what we have is we actually have 3 light rays with standard or with predetermined outcome. Okay, but of course there are multiple rays, there are millions of rays that's entering the lens, that's coming from the sources. Okay, all these light rays, they actually have different angles, different bending. Okay, the rays are being refracted differently from when it emerge from the lenses. But because we are using converging rays, converging lens, all the light rays will actually converge to a particular point. It's just that all the light rays will be bent at different angles. So what we can do is, when we look at ray drawing diagram, we actually focus very closely to the 3 rays. Because these 3 rays are the only 3 rays that have predetermined, or what we have a fixed destination. It will always bend, okay, at a certain angles. It will always cut the focal point, etc., etc. Okay, no matter what is the angle of or no matter what is where is the object, how far or how near is the object. Okay, the moment you have light ray coming from the source that cuts through this optical center, I know that will be ray 1. It will pass through optical center straight through. If it's ray 2, okay, if it's parallel to the principal axis, it will definitely exit by cutting through the focal point. How about ray 3? If I know that the ray actually passes through the focal point first, it will actually emerge parallel to the principal axis. This is what we call rays with predetermined outcome. So what are we going to do with them? Okay, this is where once I have the 3 rays, I will actually use them to determine, okay, the location, okay, of my image. Okay, so what we have is we have the object at different location of the lens in front of the lens, and we have image form. So how are we going to find or to locate the image? Okay, using ray drawing diagrams. Okay, we are going to employ these 3 rays to help us identify or locate the image, okay, formed by the lens. Okay, so there is a standard way of writing, okay, or drawing, what we call. Okay, before we move on to drawing, there are standards things that we look out for, standard symbols. Okay, the lens, okay, we don't draw the fat lens, curvy lens in when we do our working. Is a bit troublesome. So what we denote is a straight line with the arrowhead, okay, at both ends. This will denote the lens. Okay, and same thing, we have the principal axis, which is here, the principal axis here. Okay, and this is the optical center C, and is denoted by the relevant focal point. So if you look at the ray drawing diagram, before we actually proceed to draw any drawing, we actually outline these 4 items. I will outline the lens, principal axis, optical center, and the focal point first. Okay, so just a rule of thumb, know the symbols, know what we are dealing with. After that, what we have is, I will look at the questions. The question will tell me where do I place the object, and how far is the object from the lens. Okay, I will usually denote the object, okay, let's say with a symbol O, and the object distance, okay, is always measured from the object to the optical center, and I will always label it U. Okay, it's a standard symbol that we always use. Now, so what do we do now? For example, I have the object, okay, which is placed at a certain distance away from F, focal point. So what do I do? How do I draw a ray drawing diagram? I will start off by drawing ray number 1. It's always a good practice to always start off with ray number 1. Okay, where does ray number 1 come from? It always comes from the object. You pass through the optical center and you go straight through. So basically it's just a straight line. Okay, so I choose the point. I will usually choose the tip of the object. So I'll draw a straight line through, passes through the optical center. Okay, so this will be my ray number 1. Okay, remember, arrowhead, for put arrow on the line to symbolize light ray. After that, I will have ray number 2. Okay, parallel to the principal axis, and what it does is when I exit the lens, it will definitely cut the focal point. Okay, so this is what I do. I know ray 1, ray 2, ray 3, they are predetermined. So what I do is, out of these 3 rays, I actually need 2 only. Okay, so after the 2 rays, what do I do? I will look for the intersection point. Because where the 2 rays intersect, that will be the image of that particular point. So if I use the head, the tip of the arrow as my source, after drawing ray 1 and ray 2, I will have the intersection point here. This intersection point will be the image of my tip of the arrow, okay, of my object. Okay, and I will label it as I. Okay, and if I know this is the tip of the arrow, if I know this is the leg, or this is the base, I will actually be able to locate the image of my object. Okay, and from there, I can actually have multiple cases. Okay, but before we move on to the multiple cases, things to take note is I actually have a standard symbol. We actually have a standard symbol that we look out for. This will be object U, image distance. This will be the this is object distance. This will be the image distance, which is V. Okay. Now, so what happened is there are different cases. Okay, I will outline. There are 6 different cases. Okay, and two of the cases that we are interested in is what happened when the object is less than the focal point. Okay, you'll find that the rays will actually be divergent, and what happened is I will actually have what we call a virtual image being formed. Okay, there are primarily 6 different ray drawing or 6 different locations. Okay, and they are usually outlined in the textbook. Okay, so please refer to your textbook, really refer to that and see what are the possible outcomes and the possible ray drawing diagrams. You need to familiarize yourself to how to draw all the 6 diagrams. okay, the drawing. Okay, in the next video I'll actually run through how we draw the ray drawing diagrams, but for here I'll just summarize one important thing, which is the ray drawing diagram, the property of the image, location of the image itself, and the users. These are the 4 things that you need to be careful. Okay, see you.